Welcome curious minds to Pharmacept, your go-to tutorial hub for unlocking the concepts of pharmacy and science in general. I'm Solobartimeus, but you can call me J-Paps, and I am going to be your guide throughout this session. Here at Pharmacept, our mission is simple: to break down complex scientific concepts and make them accessible to everyone. If this is the place for you, don't forget to hit that subscribe button and ring the notification bell to stay updated on all our latest videos. Now let's jump right into it. In this video, we'll be dealing with functional group chemistry. Now, when we say a functional group basically is an atom or a group of atoms that helps you determine the chemical properties of an organic compound. Now, let's look at some examples right here. So we have CH3, right? CH3, which basically is drawn as C, having H bonded to it. So here we have single bonds connecting H or hydrogen and carbon. And on the other hand, we have an alkene. Okay, so let's do this. Yeah. So we have an alkene, which is C and has two hydrogen bonds bonded to the main carbon with a double bond within. So it's CH2. There is a property, okay? These atoms or these bonds are what differentiates the properties of what we have on the left hand side, which we would call an alkane, and what we have on the right hand side, which we will call an alkene. So when we look at these properties or react it with various compounds, they will all react in a different way. Let's look at another example. So let's say I have a compound such as CH3 bonded to a nitrogen, NH2, or an amine group. Okay, there is going to be a different reaction here, unlike if we are bonding it to a sulfur group. So in this case, okay, the atom which is giving it its distinct chemical property is the nitrogen here, and the sulfur in the next one. Perfect. Now we are going to look at some functional groups, right, that we will be able to identify, and we'll look at some examples of some compounds and the functional groups that we can find within them. So to begin with, we are going to talk about alkanes and alkenes, and we spoke about that in the previous example. So we have an alkane, which is a carbon with single bonds connecting. Alright, so next on the list we'll be talking about alkenes, and here alkenes are carbons connected with double bonds, as I said earlier. These are some of the basic functional groups that we can get. Next on the list we have alkynes, and with alkynes they are carbons with triple bonds, right, found in between the compound. Then we have alcohols. Let's see. Yes, so we have alcohols. Okay, So an alcohol is a carbon which has an OH group, and this group we call it a hydroxyl group, a hydroxyl or hydroxide group, or hydroxide, and as the name suggests, it's an O and an H. So hydroxyl or a hydroxide group. So hydroxyl or a hydroxide group. So next we have an amine group. As I showed you before, an amine group, it's a nitrogen bonded to a carbon. So let's look at this structure here. A carbon with its bonds around it. It's bonded with a single bond to a nitrogen, which also has bonds of hydrogen or other carbons bonded to it. So this is what we call an amine functional group. Perfect. Then now we move to a nitrile, and when we are talking about a nitrile, it is a carbon triple bonded to a nitrogen. So in any scenario you see a carbon that is triple bonded to a nitrogen, what must click in your mind is a nitrile. Perfect. Then thirdly, we're going to look at an imine. As the name suggests, it's different from an amine in the sense that it's a carbon bonded to two, or has two bonds connecting it to a nitrogen. Alright, and this is what we call an imine. And take note of the difference. We have an amine in the first one, and the third one we have an imine. Perfect. Moving on, we have what we call a thiol, and you can remember I showed you a structure before which was CH3 bonded singly to a sulfur group, and this is what we call a thiol. Beautiful. Now we move to a sulfide. So a sulfide is a sulfur group that is connecting two carbon moieties. Alright, so we have carbon bonded to a sulfur bonded to another carbon, and the carbons are bonded to whatever they bond to, and this is what we call a sulfide. Take note, a thiol is bonded to a carbon with a single bond, but the thiol is at a terminal end. It is not connecting two carbons together. But when we have a sulfur that connects two carbons together, it's called a sulfide group. Now, just to pose the question, when you hear disulfide, what comes to mind? Di means what? Two. So in this scenario, we have two carbons linked together by two sulfur atoms. So we have carbon bonded to a sulfur, which is also bonded to another sulfur, and then carbon on the other side. And this is what we call a disulfide group. Beautiful. Now we go to oxygen and its functional groups. Now the functional groups under oxygen are very vast, and they all come in different nomenclature and characterization. Okay, so we'll delve into it shortly. So we have, first on the list, we have an aldehyde. Alright, an aldehyde. So in an aldehyde, okay, we have a carbon double bonded to an oxygen and has an H bonded to it, and follows any other compound you want to add to it, be it carbons or the others. Alright, so you can continue the chain. So we have something like CH3C double bonded to an O and H. Beautiful. So this is an aldehyde. Now if we have a ketone, okay, a ketone suggests that the portion of the aldehyde that was bonded to the hydrogen is replaced by another carbon. So it's a carbon with the one in the middle double bonded to an O. and this is what we call a ketone. Wonderful. And we have next on the list a carboxylic acid. Okay, so for carboxylic acid we have double bonded to an O, and now the moiety that we exchanged before is going to be exchanged for an OH group. Then you continue the chain, so on and so forth. So this is what we call a carboxylic acid. Beautiful. Now, as you've taken note, all the atoms that we mentioned before, you could see that we are changing what the carbon bonded to the double O is bonded to, and that gives us the different functional groups that we are talking about. Moving on, you are going to see different changes to those functional groups, and you would appreciate it more. So let's move on to an ester. And now an ester, as we will all know, is carbon again bonded to an O to another O, then the carbon moiety follows, and then on the other side you can continue the chain as long as you wish. So this is what we call an ester. Okay, and it's an alkyl alkanoate. It can also be called what? An alkyl alkanoate. Fantastic. Now we move to the next one. This might sound intriguing, but it's similar to an amine. Why do I say so? The name of this functional group is called an amide. And from what we said before, an amine is a carbon bonded singly to a nitrogen. But here, this carbon is bonded to O and also bonded to the nitrogen. So note the difference. When the carbon is doubly bonded to an oxygen and single bonded to a nitrogen, it's called an amide. But when the carbon is only single bonded to a nitrogen and follows the rest of the chain, it's called what? An amide. So please, let's note the difference. This is an amide, and what we saw before is an amine. Now let's go on. We have a carboxylic acid anhydride. Carboxylic acid anhydride. This is a very intriguing one, so let's look at it here. When we said carboxylic acid is what? A carbon bonded to an O and has an OH, but here that O is next bonded to another carbon with a double bond O, and they both have their chains continuing. So we are just combining two carboxylic acid moieties to give us what? A carboxylic acid anhydride. Beautiful. And lastly, we are going to be dealing with what? A carboxylic acid chloride. I'm sure you are guessing how it looks like by now. A carboxylic acid chloride. So we all know the formula or the symbol for a chloride, which is Cl chloride. So here, what are we going to exchange the OH for? I'm sure you said a chlorine. Beautiful. So we are exchanging that moiety for a chlorine moiety, and we have what? A carboxylic acid chloride. Beautiful. Thank you for joining this session of Pharmacept, and stay tuned for our next video where we'll be dealing with functional groups in different compounds and how we identify them. I'm J Paps, and see you next time.